All right, we're going to go ahead and jump into the presentation. First, I just wanted to say thank you everyone for joining us. I'm Rachel and I'll be hosting the webinar today. We also have a couple more members of the B9 crew on here. We have Cody, who is one of our sales engineers, and Doug, who is our product marketing coordinator here at B9. If you have any questions throughout the webinar, feel free to submit them in the Q&A box and we will answer them at the end. B9 Creation's differentiated approach to solving problems with 3D printing has developed a fan base in a wide variety of industries, including jewelry, medical, aerospace, and beyond. This has positioned us to enable our customers to progress from prototyping to fully scaled production, leveraging additive manufacturing. And here you can see a sampling of our customer base across different industries, from healthcare and aerospace to consumer tech, research, and jewelry manufacturing, as well as our custom technology division called B9X, where we develop tailored additive solutions specific to customer needs. And you can see here our global network in nearly 70 countries around the world. While we're headquartered here in South Dakota, we also have offices and personnel in Texas and Colorado, as well as strategic partners and dealers across the globe. Now I'm just going to take a quick second to introduce our panelists and share a little about each of them. Both Cody and Doug are graduates of the South Dakota School of Mines. Cody is one of our sales engineers. He has a mechanical engineering background with 5+ years of experience in the 3D printing industry. Doug is our product marketing coordinator. He has an industrial engineering background and 5 years of experience in successfully developing and launching products. Okay, and now I'm going to kick it over to you, Doug, so you can go ahead and dive into more about our new ESD-Rigid resin and why anyone would add it to their resin portfolio.
Thanks, Rachel. So basically, why you don't add your ESD resin to your resin portfolio is your ESD resin can minimize the risk of unintended electrical discharge and any sort of risk of dust-based fire or explosion, making manufacturing safer while also boosting efficiency, reducing prototyping costs, and accelerating design cycles because you can get nice and rapid iterative prototyping processes down. And for example, some of the things you can use ESD resin in is any sort of powder transfer, jigs and fixtures, especially within the electronics industry, electronic housings, electrical connectors, PCB carriers, soldering fixtures, conformal coating masks, and ECD hand tools. So because it's one of B9 Creation's most versatile resins, ESD-Rigid is also powered by Mechnano's extraordinary carbon nanotube functionalization known as MechT, which makes unheard-of material properties a reality. ESD-Rigid delivers static dissipative properties to 3D printed parts without compromising mechanical performance. Now, the big question is with MechT is it's a bunch of carbon nanotube basically distributed throughout the resin, which allows it to have, just like the bullet points say, a nice isotropic and precise surface volume and resistance, high tensile strength, high HDT, excellent surface finish, and any sort of absence of carbon sloughing, where you'd end up with any sort of carbon rubbing off on the part after it's printed and post-processed. And then I can pass it off to Cody here to go over some of the ESD-Rigid properties as well.
Sweet. Thank you, Doug. Yeah, as Doug touched on, the rigid material properties, or ESD-Rigid material properties are quite unique given the carbon that's within the actual parts themselves there. The heat deflection temperature and ultimate tensile strength are quite a bit higher than most of our other resins in comparison there. And also with, given the name ESD, we have electrical surface resistance of 10 to the 8th ohms. If we can go to the next slide here, there is a chart that shows the different ranges there of the resistance classifications. So as you can see, we're in the dissipative range, above conductive, but below insulative materials. So this is still a great level to be at in terms of dissipating any electrical charges that may come in contact with your parts. And I'll pass it back on to Doug here to talk about what some of those parts can be and the use cases for those.
So we've got an example part sitting here before us here for using ESD in basically a powder-based flow application. And because of its having those electrostatic dissipative formulations within it, It allows for zero clumping, as any sort of powder-like material could be flowing through a nozzle like we have sitting here. And basically, any sort of electrostatic buildup that occurs within the powder from those particles rubbing together will then get dissipated out through the material itself, so that you don't have those electrons then causing that powder to stick together. And I've got the example both on the screen and sitting in front of me right here. As you can see, it's got that smooth surface finish. And then just kind of looking down the nozzle, the powder, as well as this webcam can see that. And this would be a great way to avoid clumping, essentially, which will keep your process flowing smoothly and efficiently. And there's some other aspects that you can use this in addition to nozzles, is any sort of like connectors, containers, or guiding structures where you might have some sort of electrostatic buildup that could then lead to a slowdown or stoppage within your workflow. And then I'll pass it off to Cody to talk here about the white paper about our ESD resin.
So one of our customers, a world-leading medical device manufacturer, actually contacted us once we had this ESD resin available or in the works there. They needed to create a nozzle similar to the one that Doug showed that would allow for powder to be fed through without clumping up to do that static buildup. So they went through our service bureau portion of our business, and we went through and validated the project, got an understanding of that, and then began printing test parts for them to validate, and it matched their needs. So we went through a full production run. They ordered over hundreds of parts, and since then they have been able to take that and move forward with their project a lot quicker than they could have previously in the past. If you'd like to read more about the white paper on that, please either click on or go to the link on the bottom of this slide here. Now, in terms of ESD, there's some slight differences in the printability, and with that, I'll pass it on to Doug to share a bit of that.
So like Cody was saying, there's some specific instructions for use here for how to use the ESD material to get the best prints available. And the big portion of it is, due to its carbon content and how strong it is, it has a tendency to stick to the build table. So we have included a wax release agent and specific ESD build tables as well. And it's super simple. It's just a small pea-sized dollop of wax that you place on that build table. You polish it until the build table is evenly coated. After that, you let the wax rest for like 1 to 2 minutes. And then afterwards, you buff it off with a fiber-free paper towel. And then after that, you're all set to go for printing. And you will have to do this for every print just to ensure optimal prints as well. And then after that, Cody can go back and explain how it fits into our engineering resin suite.
So yeah, ESD-Rigid will be joining the engineering resin suite here listed below. I'm going to go through just a general use case for these here. So the first one is a robust ABS PC. Quick reminder here, any of the plastic references that we're making are like materials. So this is ABS PC like. It has superior toughness and heat resistance. Then we have our resilient silicone. So this is an elastomeric material with a rapid response rate. Great for printing parts that need some flex and some bend in that. We also have robust ABS. So similar to ABS PC, though not quite as strong. It's got a good high impact resistance and high flexural modulus there. And it's got this lovely blue color. So a slight difference there. We also have the rugged nylon 6 material. So this is material that has a high impact resistance and high elongation. It's got some good snap and also flex along with that. So not quite as flexible as resilient silicone, but not as hard as or strong as a robust ABS PC. And finally, we have the B9 gray resin. This is a rapid prototyping resin, and it can print parts in minutes. While it does have decent qualities, the main thing is the speed at which you can print with this resin and get parts quickly out into the market there. So next, I'd like to go over the actual workflow of our print process here. So we have our process begins at the end of CAD. So you would export the part as an STL file, and that would then be brought into our B9 Create software, where then you would prep the file, you would orient it, support it, and slice it. And then that slices the file into a CPJX file, which then can be transferred to any of our printers. So on this printer, once it's good to go, if you are printing ESD resin, you need to mix that ESD resin quite well, pour it into the vat, and then apply that wax to the build table as Doug described earlier. Once that is all prepped and placed in the printer, you can then select the resin on the print screen there. You would select the ESD resin, the resolution that is available there, and then move on to the print process. After the part is printed, you can then move the piece or the build table directly to the B9 clean unit and begin cleaning that through an isopropyl wash in that B9 clean. Now, something a little bit different here with the ESD rigid resin are those CNTs, those carbon nanotubes that are in the resin. While they don't clump in the resin itself, they do like to adhere to the parts a bit more. So the solid parts require just a little bit more effort in order to get those CNT tubes off. But as along with our normal process, it just takes a little bit more effort. So it's all good there. Next, if you, once the part is completely cleaned, sorry, if we take the part and place it in the model cure unit, it gets post-cured, and then we should be all set. Now, moving on to the next slide there, we have—
Sorry about that, Cody.
No, you're good. Yeah, next we have the service bureau. So I had mentioned that during the white paper section of how our use case with what the medical device manufacturer went through. I'd like to run through what that looks like. So you need to use our service bureau services. You then put in a service bureau request with your sales representative. We would then have a meeting on consultation and the design, as well as like a timeline of the project that you have in mind. If that's validated, we would then send out a quote on these initial service bureau runs. We'd go through a feasibility print, and if everything looks good and it's approved, we go back, we do some quoting on the production run, and then we go through a full part production run and deliver those to your doorstep. So yeah, if you have more questions, definitely reach out to your sales representative there. I'd like to pass it back to Rachel for Q&A now.
Well, thank you too for that presentation. Now we're just going to take some time to answer the questions that were submitted throughout the webinar. If you have any questions and you haven't already, please feel free to go ahead and chat them in now. Okay, so the first question we have is, which B9 printers are compatible with ESD-Rigid?
Fantastic. I can take that one if you don't mind, Doug. It is available on all of our current printers in the core series.
All right, and again, this could be for either of you. What is the resolution?
Take that one as well. It's going to vary depending on the printers and the X and the Y dimension, of course. From 530 to XL, that'd be 30 micron in the X and Y to the 65 micron in the X and Y. And then in congruence with our fast technology, you can effectively half that, right? So it goes plus or minus 15 to plus or minus 25 roughly. And then in the Z height or Z dimension, that's going to be 50 micron across the board. So.
And what is the surface finish like?
I can take that one. So the surface finish on the resin is very smooth. It is probably one of the higher ones in our portfolio for having really nice, precise, smooth surface finish.
And we have another question here. Is mixing needed before use?
I can take that one as well. We generally just recommend that you shake the bottle well before use and pouring it into your print. But other than that, there isn't any sort of mixing you need to do after you pour it into the printer. Again, just shaking the bottle before you pour it into the vat is all that is needed.
And then we have a question here kind of about the washing process once the part is printed. Will ESD contaminate the normal wash?
I can take that one. While the CNTs do come off and start floating around in that isopropyl, That's not going to interrupt any other portion of washing with other resins. It's just a matter of those adhering as necessary. But as said before, if run through the normal process in the clean unit, those CNTs will wash off and within the isopropyl and not on your parts.
Okay, and it looks like those are all the questions that we have. If you would like more information about ESD-Rigid or any of our other products, or if you'd like to request a sample, schedule a product demo, or just talk to one of our solutions experts, please feel free to contact us at the email address or at the phone number listed at the bottom of the slide. Thank you again, everyone, for joining us.